Right. Hello, everyone. My name is Sonja Lavonen. I'm from Central Balticum Foundation, and I would like to warmly welcome you all to follow our ReNutriWater project results webinar. Our project has been co-funded by the Interreg Baltic Sea Region program. But before we start, I would like to give one practical instruction. So those of you who are following our webinar live, you have the chance to participate in the webinar through our chat box. You can find it on the right side of your screen, and you can place comments or questions at any time throughout the webinar. In the end, we will then have a separate moment in the agenda where our experts will address these questions. But indeed, no need to wait until that begins. You can submit your questions through the chat box already before that. All right. But first and foremost, I would like to introduce our excellent project leader, Clara Ram from Chamber of Economy Polish Waterworks. She will give you a short introduction about our project and water reuse. And after her, our other experts will follow with their presentations about our project results and activities. But please, Clara, if you're ready, then we can start.
Yes, thank you. Thank you, Sonia. Thank you, dear participants, for joining us. We welcome you to a webinar dedicated to the result of our ReNutriWater project, titled Closing Local Water Circuits by Recirculating Nutrients and Water and Using them in Nature. So we are 14 participants, 14 partners from 5 countries in the Baltic Sea region, so from Denmark, Finland, Lithuania, Latvia, and Poland. We want to share the project latest achievement and show you how you can all benefit from them, as the project products are available on the Interreg Baltic Sea website. So urban wastewater is primary water. We know that over 99% of it is just water. But how do we eliminate the less than 1% of contaminants, dangerous microbiology, and unwanted pollutants to obtain this reclaimed water that is safe and has the desired nutrient content? But why in the Baltic Sea region? There is plenty of water here, isn't it? It's not so obvious when we look at scientific research and our own local observations. We can see, and it is proven, that air temperatures are rising and the sea surface temperatures are also rising. And there is an increase in river water levels in winter and a decrease in spring floods. The primary factors contributing to the eutrophication of the Baltic Sea are external nutrient inputs from land and atmospheric deposition of nutrients. These factors mean we must conserve freshwater resources and seek innovative solutions in our region. We also have to consider that drinking water isn't universal, isn't suitable for every purpose. In addition, nutrients are too precious to be wasted. And as I have already shown in previous slides, wastewater can be a source of fit for purpose water. So we decided to address this issue to check how to locally recover and reuse water. And initially, we relied on the only EU regulation from 2020, the 741 regulation. It regulates the quality of reclaimed water and the organization of water reclamation project. So you can see it outlines the principle for organizing the cooperation between wastewater treatment plant operator, reclamation facility operator, and after reclaimed water user, as it's shown on this slide. Its quality requirements are so universal that it serves as a good starting point, but please note that does not exhaust the type requirement for reclaimed water quality. We couldn't tackle everything and solve every problem. Therefore, we decided to choose three key issues, the details of which my colleagues will present in a while. We conducted three pilots. The first concerned the disinfection of treated wastewater and reclaimed water to ensure the safe use. The second pilot involved controlled irrigation of selected plants. In the city, there were lawns and flower beds, and it is from this photo, right side photo from Jurmala. The third pilot focused on greenhouse plant cultivation. We built 4 greenhouses in 4 locations, and there you can see the picture from Samso greenhouses, and we compared the health of plant watered with water of different compositions. So now my colleagues will share with you more details on it. Thank you.
Thank you, Clara. Thank you for this introduction. And as you pointed out, the water resources are not endless, and not even the country which is filled with lakes and water and has water all around. And I'm now talking about Finland, from where our next speaker is coming. My dear colleague Monika Wojciechowska from Savonia University of Applied Sciences has been part of all these three pilot activities that Clara already mentioned here, and she will now give you a general overview of our pilot activities. So please, Monika, when you are ready.
Okay, thank you. In this part of session, me and my colleagues will present how the pilots have been translated into practical applications. 3 pilots in the ReNutriWater project evaluated the feasibility of reclaimed water use based on local wastewater treatment plants conditions, highlighting the challenges faced in water recovery from municipal wastewater. If we see on the project construction, the pilots were part of work package 2, where out of 5 activity groups in this work package, 3 were intended for piloting. In pilot 1, the goal was to test how effectively different disinfection methods can make reclaimed water safe for reuse. In pilot 3, the aim was to adjust the nutrient composition for reclaimed water, like nitrogen, phosphorus, and potassium, to meet crops' needs. And in pilot 3, the objective was to overcome barriers to using reclaimed water in greenhouses by testing its safety for plants watering. On project realization schedule, assumption for piloting was prepared in work package 1 in first year of project, then preparation to piloting in work package 2, like procurements, ordering equipment, began in mid-2023, and most of piloting activities was carried out in mid of 2024. Pilot 3 was also independent on the seasonality of crop cultivations. The pilots took place in 4 countries, as was mentioned by Clara: Finland, Poland, Latvia, and Denmark. Nutrient content in Finland, Poland, and Latvia. Disinfection water was searched by Finland and Poland, and greenhouses was prepared by all 4 countries, I mean Finland, Poland, Latvia, and Denmark. Our reused water was supposed to be tailor-made, fit for purpose, and considered with a holistic approach, taking into account 3 main aspects: regulatory, ecological context, and economic consequences. We were intrigued by questions: do the lab tests results meet with reference value of legal regulations? Is it eco-friendly, and does it contribute to sustainable development? or reduce water scarcity? Does it contribute to reducing the consumption of tap water or the discharge of wastewater? The main document we're referred to was European Union Regulation 2020/741 on minimum requirements for water reuse for agricultural purposes, and it is obvious that wastewater leaving the treatment plant must first of all meet the requirements of the Urban Wastewater Treatment Directive in terms of physico-chemical characteristic of wastewater quality, microbiological indicators before it is recycled. In case we did not find a reference in the mentioned regulations, we search it in other European or global regulations. We invested in safe, disinfected, reclaimed water and in the construction of greenhouses. Then we received the results of our reclaimed water and, in cases of greenhouses, additionally the result of soil and plants. Our wastewater treatment plants differed in size, technological processes, physico-chemical and microbiological composition, and nutrient contents. However, in each case, we managed to obtain safe reclaimed water suitable for use with additional values, nutritional values if it was needed. Our project proves that reusing water isn't just possible. Is it safe when backed by strong legislation, best practices, and advanced technologies? We faced a big challenge. For example, farmers often lack awareness, and treated wastewater from wastewater treatment plants is still wasted. Water reuse turns that problem into a solution, fighting water scarcity and pollution through collaboration and innovation. With the right regulations and technology, reclaimed water becomes a reliable resource. The benefits are clear: fewer nutrients entering waterways, healthier crops, and less pollution in the Baltic Sea. Best practices matter: keep storage short, minimize nutrient loss, and ensure proper disinfection. Innovation drives efficiency through data and strong partnership. Community engagement builds trust with open greenhouses and seed to harvest demos. Technology seals the deal: membranes, ozonation, and UV guarantee quality. Looking ahead, this approach supports sustainable agriculture and integrated water management. That is all from my side. Thank you for your attention.
Thank you, Monika. The last highlight pieces you saw in Monika's last PowerPoint slide can be actually found from our project LinkedIn page as well. We had a separate campaign where all our partners were able to highlight a couple points from their activities or results and learning. So take a look at those, and you can find our profile by the name of ReNutriWater.
Thank you.
Thank you. And then let's continue next our journey to Latvia and Riga, from where our next expert is coming from. Oskar Purmalis from the University of Latvia will now move the focus towards the research side of the results. And please, Oskar, if you're ready, then go ahead.
Dear participants, I would like to tell a small insight about the scientific approaches and findings what we found in our project and when we were realizing all the project activities. And what is the importance of this usage of reclaimed water? And first of all, why we are studying this in Baltic Sea region? Because in this area, some of countries is not allowing to use in agriculture purposes reclaimed water, although big part of the Europe already is using it. But when we are looking on the future perspective, then of course we can start to realize that in summer seasons, when it will be very crucial access to the water resources for agriculture purposes, we can see some increased risks. And therefore, like if we like early already start to study and discuss and implement technologies for preparation, usage, and risk management, it could be a much safer future for us and managing these risks towards climate changes and extreme events, for example, droughts. But during the project activities, it was very nice insight when we are like realizing saw plenty of pilot territories and with different sizes of wastewater treatment plants. And this gave us like a chance to like quite frequently analyze, more frequently than is like in requirements suggested. And it showed like annual fluctuations and even monthly or between the weeks. What happens with water flow and what kind of quality of the water we get in treatment plant and what is coming outside, which could be like used for preparing reclaimed water. In this case, also give a lot of insight what kind of chemicals appear if we have, for example, industrial sector in particular city or municipality, and the same if this particular treatment plant is connected with like a rainwater collection and therefore like get some also big proportion of rainwater in this treatment plant water flow. But as a very big success, I would say, for this project was that our results was sharing with society, water professionals, industries, and also like organizations responsible for legal requirements, and also they all are interested in these findings before deciding if they need to like start to like more quicker or with a slower pace to prepare regulation and maybe permissions to allow use that such kind of waters in agriculture. But when we are looking deeper in these pilot territories about this composition of reclaimed water, then we can see that of course this end water like product what we're preparing, it differs by composition from these two sides. So one is like what kind of water we're getting from treatment plant, another what kind of additional pre-treatment or disinfection method we're using, because to prepare reclaimed water obligatory requirement is disinfection. But since disinfection methods differ, doses differ, then we need to understand what kind of water we are using and what is our aim for this reclaimed water usage, or it's for food production, or just energy cultures, or for the pasturing, for example. And therefore, there can be differences. But as we can see, some of these big facilities reach quite nice results in respect to absorbing nutrients. In this case of reclaimed water, maybe also we'd like to see some nutrients still left in this water or higher concentration. And this kind of access provides smaller treatment plants actually, because although they are like work quite efficiently by reducing pollutants in water before releasing back in the nature this treated water, but as we can see, still with the nitrogen is still some problems. Although they meet requirements for reduction efficiency also towards nitrogen, but we can see that there's still left some nitrogen and phosphorus in the water, which can be assimilated through growing crops, and then like this water could be like then only reach Baltic Sea with much less nutrients in them. Therefore, like mitigating also eutrophication of the Baltic Sea. But since we have different kind of water quality, what comes out of the treatment plants, no slight fluctuations, it's not like drastically big changes, then we can also decide if we want to use such kind of water, prepare reclaimed water, like what kind of aims for this quality class for reclaimed water. We can decide what kind of technologies we should implement or improve or already in existing facilities, and maybe we can leave this existing facility as it is and only add like tertiary or next stage of pretreatment, not for the whole flow probably, but only the flow which will be used and prepared for reclaimed water. And therefore, we can see also some results of tested like methods. So in water preparation, like coagulation, sun filtration, active carbon, and so on. And as we can see, that these technologies greatly can help improve water quality before disinfection. Because if you are taking, for example, chlorination, we would like to see as less as possible, for example, organic matter. The same if you're using UV radiation for disinfection, that we would like to see very low turbidity to not reducing disinfection efficiency. And therefore, again, we can step back what kind of quality we have and what kind of the aim for the reclaimed water quality we have, and we can decide and adjust these technologies and choose looking on these expenses and our needs and also the water quantities, because some of these technologies, of course, wouldn't be very cheap if we using for very big quantities of water preparation. But when we are looking deeper in these disinfection methods, because it's obligatory to disinfect these treated wastewaters to call them as reclaimed water for reuse purposes, we need to disinfect, and then there appears quite a wide range of methods how we can do it. And as we can see, although the cheapest one, like chlorination, this chlorine is not very helpful for the plants, but even with quite small concentrations, we can reduce significantly concentration of E. coli, enterococci, other microbiological agents, and it's negligibly only increase chlorine content in the water. Therefore, we can still also stick sometimes with chlorine if we try to use that in agriculture purposes. But other methods also showed their advantages to reducing content of microbiological pollution in the water. But some of them, of course, affect also other components in the water. For example, ozonation, although they effectively reduce this microbiology, there can be slight increase of biological oxygen demand and chemical oxygen demand. But still, it is possible to meet this highest quality of reclaimed water looking on these requirements. And as I said, also UV is also effective. Can adjust very easily for different purposes, but of course, very big flow or turbid flow of the water could make some difficulties. And also here, in our project partners tested that in some smaller dosages of UV could be effective. But very small ones reduce this microbiological pollution levels, but still we cannot reach zero with very small dosages. And also there is different approaches with adding other chemicals. And one of them is quite widely, I would say, sometimes used, sometimes not, is percetic acid, which is like organic acid, which can biodegrade very quickly, and therefore can be also effectively used. And also in one project, pilot territory also was applied this method with this acid, and it's with dosage of 100 ppm, which is quite high. I would say it was possible to reduce microbiological pollution till zero. There was no survived microbiological agents. But of course, to get rid of hydrogen peroxide, which also is present in these disinfectants, there is some visible increase of biological oxygen demand, and also agents to fight with this hydrogen peroxide also can create small minor changes in the water composition. But again, depend on our purposes, this dosage can be adjusted. Therefore, reducing this potential changes of the water, still meeting requirements for this highest class of reclaimed water quality. But when we are discussing with stakeholders, also organizations which is responsible for implementing legal requirements, always also touching these questions about emergent pollutants. because as we know from literature, other case studies, the same also in our project pilots, we noticed that we have some small concentrations of different emergent pollutants, for example, leftovers of pharmaceuticals present in the wastewater. It's nanograms, sometimes micrograms per liter. It's small concentration, but still present. But when we are preparing reclaimed water with obligatory the disinfection method or just pretreatment or ion exchange resins, we can significantly reduce also those risks. And as you can see in the table, although there's a lot of these rows and columns, for example, if you pay attention to the ozone and inlet, these numbers, these differences, you can see that ozonation, for example, is not very effective only on reducing microbiological agents in the water, but also significantly reduce these emergent pollutant concentrations. And majority cases, even so small, like this reduction rate was so high that very sensitive instrumental methods cannot even detect anymore these pollutants in the water. Therefore, I would say that water quality can differ, and also our aims can differ where we can apply this reclaimed water, or it's street cleaning or this agriculture purposes. But available technologies and their adjustments and possibilities to adjust can provide for us also safe strategies for preparing and using reclaimed water. Thank you.
Thank you, Oskar. So quite positive results then, I would say. We were lucky to have several university partners in our project to conduct this research on these methods and pilot results. So besides University of Latvia and Savonia, also the Warsaw University of Technology did actually very extensive work on these matters too. And if you want to find out more, please check our project website, and there's this solutions tab, and from there you can find all our project outputs and publications as well. So more info available there. But good. So let's move from research to practice. Next, we have two different sizes of wastewater treatment plant operators upcoming, and they are sharing their learnings from the user side. So first, from Riga, we travel to Ukale and give the floor next to Janis Sietris from VNK Service, who has been actually working together with Oskars quite a lot on our pilots. But please, Janis.
Good morning, everyone. So, yes, I'm representing probably the smallest wastewater treatment plant within this project, as we have just only about 1,000 person equivalent within the treatment process. But surely we have some takeaways from this long-term project. And I will not go deep into the results as to the measurements, but mainly focus on some important issues that might be interesting for small-scale wastewater treatment plants. And I could say that the usage of reclaimed water may not be possible in all small-scale biological wastewater treatment plant, because it depends on both the wastewater treatment technological design used and the regulatory requirements for treated wastewater. It means the local requirements. The risk analysis is the first essential step to take before deciding on the reuse of treated wastewater. We have to know the factors affecting seasonal wastewater quality, such as acceptance of content from individual wastewater treatment plants for centralized wastewater treatment, fluctuations in infiltration from the pipelines, and the precipitation water volumes runs into the sewage system. And most important, the habits of users of the centralized water supply and sewage systems. And reliable and sufficient data of treated wastewater quality is the next essential step in predicting possible changes in treated wastewater quality in order to be able to adapt to the different reuse scenarios. have to say very often it's difficult to educate a society where drinking water resources are sufficient and they're considered as a natural phenomenon, just without understanding that there is a team of specialists work around the clock to ensure the safe preparation and supply of drinking water without interruption. So let's just imagine that you're buying the milk or lemonade or some stronger drink at the store, and how you would feel if you poured the content of this drink into the lawn without even tasting it. That's how we feel actually at the water company. And yeah, apart from the measurements, we see that in Latvia, the reuse of the wastewater is currently more important in populated areas where drinking water treatment facilities are unable to provide sufficient flow and pressure in drinking water transmission and distribution networks during the hot dry season, when the most users simultaneously turn on their taps and begin to water their lawns and gardens. Yep. So this causes the headaches for virtually any small water utility, creating risks of the technical damage. So drinking water treatment plants are operating at maximum capacity. Pressure boosting pumps or water towers are working at the maximum range. And then imagine all the users simultaneously close their water taps. A sharp drop in water consumption causes hydraulic shocks, stirring up the sediments into the pipelines, which under normal water supply networking operating conditions ends up in the consumer's water taps. This may be a slight exit generation, but the risks of any technology must be assessed based on the worst case scenarios. And what we see, as we do have in the region, many individual wastewater treatment systems and individual drinking water supply wells. We see that it's necessary to educate the individual water resource users who already use treated wastewater for irrigation just without the necessary prior knowledge, because this creates the potential pollution and the health risks. As we know that untreated wastewater spreads disease, and as Oscar already mentioned, it's very important to know the really importance of the disinfection of the reclaimed water. So lacking of the knowledges and untrained users irrigate the lawns and the trees and the flowers incorrectly, which might be pretty dangerous. So these were my takeaways. Thank you for listening and taking a part.
Thank you, Yanis. As you mentioned, educating about the water use is very important, and not just the users, as you mentioned, but also it's good to about the risks about the users, but also the general public and young professionals, so to say, as well. And actually, we were quite lucky to have these meetings and excursions to our plants and pilot stations, and so we were able to bring stakeholders and university students as well to visit our pilot stations. But thank you from this presentation, and now we'll move forward to a little larger scale, so to say, when our project partner from Warsaw Waterworks, Joanna Sorska, will share the user perspective from a little bit larger wastewater treatment plant operators' point of view. So please, Joanna, if you're ready, then let's move on to you.
Hello, everyone. I will start with a few words about us. Warsaw operates the largest urban water and wastewater system in Poland. One of our wastewater treatment plant, Czajka, has population equivalent over 2 million. We deal with very high hydraulic loads, significant daily variability, strict environmental requirements, and increasing pressure to adapt to regulatory changes. As a modern company, we also aim to transform into a circular economy model. For such a system, the question is not whether water reuse will be needed, but how quickly we can prepare scalable solution for it. The revision of Urban Wastewater Treatment Directive and Regulation from 2020 on water reuse established very high expectation, stable removal of suspended solid, elimination of dissolved pollutants, reliable disinfection, and control of micropollutants. For large agglomeration, these requirements are not optional. They are becoming the new baseline. Pilot 1 that we prepare with ReNutriWater project was designed precisely to test whether we can meet this expectation in real large-scale operational environments. As you can see, the technological scheme, our pilot station has two modules. First module, we test pre-treatment, and it was drum fabric filter and ion exchange design. And the second one was ozone generator, quite a common technology. So for the first model, we were testing those two technology, and we took three criteria: physiochemical parameters, operational cost, and capital cost. For the next station for our pilot, we choose ion exchange design because it has lower capital cost and a better physical chemical parameters improvement. But of course, our goal in our pilot was to achieve stable Class A reclaimed water. So a few key findings from Pilot 1. A few words about technology. Fabric filters had excellent hydraulic resilience. Even during significant variation in flow, which are quite typical for large agglomeration, the process maintained low turbidity without clogging. Ion exchange resins deliver excellent performance in removing dissolved and fine colloidal substances, but unfortunately, it was quite more expensive in operational costs. Ozonation provide a very highly effective disinfection and advanced oxidation process. It ensures full microbiological disinfection, reduction of micropollutants below the limit of quantification. However, the crucial is to have low turbidity and low organic load in pre-treatment. So what are our idea in our big agglomeration to use to our water reuse? For sure, municipal services like street cleanings or irrigation of green areas. We also talk with industry, so we can use our reuse water in their cooling system. And also, I would like to highlight that for a couple of years, we use reuse water for internal use. So for equipment washing and process support system. And what are the conclusions from the ReNutriWater project? The pilot provides something that cannot be obtained from modeling or laboratory scale testing. real operational data under real stress conditions. The technology we used, fabric filtration, ion exchange, and ozonation, together form a solid basics for safe and stable water reuse in large agglomeration. ReNutriWater demonstrates that reclaimed water is not a distant future topic. It is a technically feasibly regulatory aligned and scalable solution for cities. Now the challenge for us is to put it into a full-scale implementation, which will require both time and dedicated space, which is in the existing treatment infrastructure. Thank you so much.
Thank you, Joanna. Looking very much forward to that implementation stage. And having this practical knowledge is also very important for our results and directing the future work and initiatives on this field. As is also understanding the business side of water reuse, of course. So next, our expert, Professor Marcena Small from the Mineral and Energy Economy Research Institute of the Polish Academy of Sciences, will share some insights from this sustainable business model work that we have completed in our project. And after that, she will also follow with the introduction of our practical WaterSafe IT tool and also give some insights from the mentoring program. So please, Marcena, if you're ready, go ahead.
Thank you, Sonia, for nice introduction. Good morning, everyone. Next to the technologies that are the core of our project dedicated to the water reuse in the Baltic Sea region, the very important aspect is also the business approach. And in my presentation, I would like to show the different perspectives how we can take into account the business areas for water reuse technologies. In these three areas, business models, IT tool, and mentoring program, because all those elements support the business implementation for the water reuse technologies. So what we have to think about in the first place when we operate some company, in our case, that's the wastewater treatment plants, the very important is to create the business opportunities for the technologies. And we have to consider which kind of the business elements we could propose to our possible customers. And in the wastewater treatment plants, there are three different elements that support the implementation of the circular economy in the water and the wastewater sector. And that's the water pathway, energy pathway, and material pathways. And those three pathways, they create something like wastewater treatment plant for the future, where we can implement also the water reuse technologies. And in our project, we mainly focus on the water pathway. However, we have to also think about the raw materials, because partly we also examine the nutrients content in the reclaimed water and directing it for fertilizing purposes, which is very important. And I'm very happy that it's also included here. And also the energy, because energy generates the higher number of the cost in our wastewater treatment plant. However, in our project, we mainly focus on the water pathway, as it was already presented by my previous colleagues. And we focus in our business model preparation on the water pathway. And what is very important in the development of the business model that is dedicated to the circular economy implementation, that we have to propose the value which is in the line with the circular economy products or circular economy services. And based on the definition of the circular business model, we should have something like that. And the wastewater treatment plant is a very nice example of the place where we can create both the products and the services, because the technology at itself could be proposed as a circular economy service, where we treat the water and propose to the customer, and also we have the products with added value for the circular economy, which is water that could have the added value with the nutrients. So this is our value proposition. And in the business approach, also very important element is to propose some kind of the model, which is business model, based on the already good examples. In our case, we have selected the business model canvas for the circular economy implementation, which we call the circular business model. For water reuse technologies in our product, and it is based on the concept of the that was developed many years ago, which includes the 9 elements on the one Canva that are dedicated to the business model development. And here we have to take into consideration our partners who are actively or not actively participate in the implementation of our technologies, the key activities that we offer to our customers and that we have to take into account during our operation if we would like to propose the circular economy example and product or service. Value proposition, this is something what I already mentioned, because we have to start from this one, and it connects everything together. We propose our product or service in the line with the circular economy. Also, what we have to take into consideration, that's of course resources that we have, the people, know-how, financial resources, the customer relationship. It's also important because in this new regulation dedicated to the water reuse of the European Commission, we are strongly underlined that we have to create the promotion and information campaign to the various stakeholders, including the local communities. So also to create the good customer relationship, because in the water reuse technologies, our customer, that's mainly the local stakeholders as farmers, for example. So this is very important social element. Also, the channels that we inform the people and we create those relationships, the customer segment, we have to evaluate which kind of the partners we have, and we will have to have also the new one. Of course, the cost structure and revenue streams. If we would like to have some new income to our budget, and we also have to evaluate the cost that we have to have during the implementation of the technology on the investment stage, but after also on the operating stage. And in our project, we have also added the 2 additional elements that you can see on our Canva. That's the environmental impact and benefits evaluation, and also the social impacts and benefits evaluation. What I would like to underline here, that the development of the business model canvas and proposition of the circular economy added value, that's not the economic evaluation. That's the business approach, that where we propose some elements that we have to take into consideration. And cost evaluation, this is important element of it, but here we define the cost and the additional evaluation with the usage. For example, life cycle cost assessment is like additional tool that could support the development of the business model canvas. And what is very nice, that we were able to create the business model canvas for all our pilots and for all our case studies that have been presented during previous presentations. And in our methodological approach, we have used the survey questionnaire that we distribute to our partners, and then we had the individual meetings with each of the project case study. to create the individual business model canvas for the circular economy implementation with the added value for the which is the reclaimed water here. And here are some key messages from the development of the business models. Of course, we have the case studies around the Baltic Sea region, but that's the very different elements that have to be evaluated on the local scale. So the local conditions are the most important to be taken into account during the development of the business models. Water reuse supports sustainability requirements, so we are also able to report with the use of some of the indicators that the water reclaimed water that we are generating is one of the sustainability indicator. Municipalities are critical players in the wastewater reuse implementation because they have the power to make decisions, and they are the decision bodies for the local wastewater treatment plants. Farmers in parts of the Baltic Sea region suffer from seasonal water shortages, which was already presented as well. That we can think that we have a lot of water around the Baltic Sea region, but that the local conditions are very different, and in the future, more and more farmers will suffer from the water shortages. A circular economy business model is not the economic model and economic analysis, which I mentioned before, and starting from the ground up with potential customers, we have to demonstrate the results, convince them, and show some benefits to implement the water reuse technologies. And what is very important as well, the current water reuse technologies deliver, of course, the sufficient results, and their successful implementation depends upon integration into appropriate business and market conditions. So we have very nice technologies that were implemented with the huge success. However, we also have to support the commercialization and implementation, further operation of those technologies with the usage of the business approach. So thank you very much for this part, and I will go directly for the second part, discover the WaterSafe IT tool, making water reuse easy. The second element that our institute was responsible for, that was the development and implementation of the WaterSafe tool. And it's the IT tool that aims to promote the protection and reuse of water from the wastewater. And the main function of our tool was to make the calculations based on the wastewater parameters that the user could enter and select the optimal purpose for further use of reclaimed water. The instruction for the WaterSafe tool is available on the web page, and of course, everyone could access this tool and check if your parameters that you have on your wastewater treatment plant or wastewater treatment plant which you operate with is possible to evaluate if you could, which kind of the technology is recommended for your wastewater. With the, of course, some parameters and some conditions that we have to enter to the tool, that we have some of the recommendations. So in the first place, we have to enter the data regarding the wastewater treatment plant and wastewater. We have to select the target water quality class. We are providing the automatic analysis that is based on the parameters that are entered by the user, and the final treatment recommendation, which you will have in some kind of the report with the indication which kind of the technology is the most recommended for your parameters and also for the water quality class that you would like to achieve from your wastewater. And then you can download the report in the PDF format. This is quite easy for the users. And I think that also the graphic design is understandable for the further usage. And our approach was to make the water utilities operators more familiar with the possible water reuse technologies. And also, this is the quite easy tool to also be presented for the municipality operators and decision makers, that something like this is available, and we can initially select the treatment method that could be implemented in our wastewater treatment plant in the future. And here, of course, what is important, and this is the base of our ReNutriWater project, that we have the water reuse regulation with the specific classes of the water that we would like to achieve. And in our calculator, you can, as a user, you can select to which class you would like to treat your wastewater. So it's very important because there are different purposes even in this regulation, but there are also different purposes in our project that we have used the water reuse technologies. And here are some of the print screens from our WaterSafe IT tool. If we would like to use it, if you have some data from wastewater treatment plant, or you can download from the internet or from some articles, you can try and test how it is working. This is the characteristic of the treated wastewater that you implement to the IT tool, and here you have the information to which class of the water could be treated, and the most important, the recommended technology for you, with the indication which one is the most recommended. So it could be quite useful tool for the companies that are starting to think about the water reuse technologies, but they don't know what to consider. So we offer this solution for them, of course, for free, and you can access this one on the webpage of the Clearwater cluster. And now I will go directly again to the lessons learned from our mentoring program. That was our third proposition, how to make it happen in the new wastewater treatment plants. So that's mean making happen the water reuse technology implementation. We wanted to support the external companies, not only companies that are involved in our project, but also external, in considering the implementation of the water reuse technologies in the Baltic Sea region, and not only because our requirement process was open for the all people who and companies from Europe and abroad who would like to think about and implement in the future water reuse solutions. And we propose the mentoring program that had some specific assumptions. So the basic of the mentoring program is that mentees, that's mean the participants, are working with the mentors, that's mean experts from our project, and they are developing the action plan how to implement the water reuse technology in their companies. And we have proposed the structure of the mentoring program that include the joint workshops with experts about the circular economy business models. The second one, this was dedicated to the risk management, that is integral part of the water reuse regulation and has to be developed if you would like to implement this regulation in your company. And the third one was dedicated to the IT tool. We proposed the IT tool and also test with our participants. The second element includes the individual mentor and mentees meetings, and that were minimum 4 individual sessions, and many people meet more than 4 times during this half of year. to have some discussion to help our mentees with the development of the action plans for the implementation of the water reuse technologies. And there was also, of course, the joint meetings where we wanted to know each other, what we are doing, which kind of the goals our participants want to achieve as well. And the specific objectives of our mentoring program. In the first place, it was the directing participants to the areas of the water recovery and nutrients that can be implemented in their units and to evaluate if it's possible or what is recommended for them. Also, the main goal of the mentoring program in general, mentoring programs, is to stimulate the creativity for the participants, what they could create for their companies, and how also the company could benefit from their participation in the mentoring program. Also, we wanted to make the participants more familiar with the specific of building the new business models that I have presented, because also one of the tasks was dedicated to the evaluation of the business areas that would be important during the considering and implementation of the water reuse technologies. Of course, we wanted also to raise awareness of water reuse and the importance of water. In our mentoring program, our goal also was to popularize the results of our project, because those elements that have been taken into account during the workshops, like IT tool, risk management, and business models, that are the results of our project as well. And we wanted to assist in the implementation of the water reuse solutions in the organizations of the participants, who are also our target groups. And the expected result was the action plan that they had proposed for their companies. And here you have the information which companies have been taken part in our mentoring program, which was created for in general, the meetings were in 2025, but of course the development of the mentoring program has started already in 2024, and the mentoring program is already implemented and closed. Thank you very much for your attention. That's all from my side.
Thank you very much, Marcena. I have one tip for the audience. You can also find a short step-by-step tutorial video about this WaterSafe IT tool that Marcena introduced. It's on our website, so you can check it out from there if you want some hands-on instruction on how to use the WaterSafe tool. But also, if you want or need a bit more comprehensive guidance, then you can also take a look of a webinar recording where the tool was presented. So that's also available on our project website. And never forgetting to contact our experts directly. All right. But to conclude the presentation side of this webinar, I would like to invite back on the stage our project leader, Clara Ram, who will then introduce you our handbook of water reuse. So please, Clara, go ahead.
Yes, thank you. Thank you, Sonia. Thank you. Yes, I wonder what can I add, because all was presented and my colleagues really exhausted all the issues. So a few words about our knowledge and experience compendium. So our handbook, we are very proud to have collaborated on this handbook. It is available in English on the project website, and the Polish version will also be released next week, very soon. So the handbook was developed by people with various expertise. This includes infrastructure operators, local government representatives, scientists, representatives of interest groups, or stakeholders. And thanks to our collaborative efforts, we have developed this compelling document. I hope each of you will find something interesting in it. Also, detailed description of issues already mentioned by my colleagues. So, a bit about the table of contents of this handbook. So the pilot owners have provided description of their work, so the drawing to present the pilot diagrams, and you can find the descriptions and basic parameters here. And also we prepared a very detailed analysis of the efforts of water post-treatment before disinfection, so pre-treatment before disinfection. Here you will find graphs resulting from the tests concluded. And the pilot owners have also prepared information from target groups. The subsequent sections of the handbook present our other projects. So we can see here that we have IT tool guidelines, decision support tool is guideline for risk assessments as well, and also business models already described by my colleagues. And what is also interesting, I hope can be very interesting to all of you, to all of us, is that we conclude with education presenting the foundation of a successful stakeholder meeting. As you can see, this is a really interesting compendium of knowledge-based experience here. An example of pilots, we present a lot of graphs, etc. We also devote a significant part of this handbook disinfection methods, already mentioned by Oscar. So a wide variety of disinfection methods are available, each using different mechanisms to achieve microbial inactivation. But we concentrated, as this was already mentioned, on chlorination, UV, and ozonation. So there is a description about pros and cons of every method. I will not repeat it, but yes, you can see case studies, you can see result like this one, result of test that were concluded during testing phase. So a case-by-case assessment supported by experimental testing is recommended to identify the most effective approach, and we provide knowledge how to do it. Implementing where suited microbial inactivity strategies can greatly enhance the efficiency and reliability of the reclamation processes. Because the most important thing is to keep this project safe. And this slide shows the effects of changes in nutrient content as a result of various treatment methods before disinfection, such as coagulation, filtration, and sorption on active carbon. So you can really see that there is a lot of concrete examples in the handbook that you can read, analyze, and take your also conclusion and provide solutions to your own project. I would really highlight, and I already mentioned it, and we showed it, how to prepare for a meeting with stakeholders. So the last part of the handbook is really a lot of information how to prepare for a meeting with stakeholders, depending on their level of interest and also influence they have. So there is a different approach toward the local public authorities, infrastructure operators, and other stakeholders we have to approach. And there is a number of guidelines you can use. And also we demonstrate the elements of good conversation so that we solve the problem and do not disappoint stakeholders. So some questions and answers that we can use. So just to summarize, the presented project results contain really many interesting details, so we encourage you to familiarize yourself with the handbook, which is available on our ReNutriWater website. We have compiled practical tips for managing processes and collaboration, and all information, including the IT tool and all details of the handbook, business models are to be found on the ReNutriWater website. Most partners will also continue their work on water recovery and reuse, so we invite you to collaboration, to just collaborate, also to contact us. And really, one more thing I would like to highlight, that nothing happens without good cooperation. And therefore, I would like to thank all my colleagues on the project for their commitment and cooperation. It's true that we are very diverse, but this is one of our invaluable values. So thank you all for making the project a success. This wouldn't have been possible without you. So thank you a lot. Thank you.
Thank you, Clara. Very good to conclude with the most important thing in the end. So yes, from my behalf as well, thank you all of our experts who have been presenting here today in this webinar. And just like Clara said, definitely not forgetting all the rest of our project partners as well, who have done very, very extensive work throughout this project and made it possible to have this results webinar today. And also we actually have a meeting next week in Warsaw as well, where we share more our results.
Yes, and the conference, yes. Just
Conference, yes.
that we have this international conference, so you are all invited, and on 10th of December, and also last partners meeting in Warsaw.
Yes. For the audience, I would like to now point out that all these webinar presentations from today will be shared on our website. You can find from the Solutions Lab, when you scroll down, there is this downloads section, and our presentations will be uploaded there. So you can find them from there later on. And also this recording will be shared on our project website as well. But then we'll move on to our final stage of this webinar. And so we still have our questions and answers session. And those who are following the webinar live stream, you can place your questions in the chat box, and we shall then address them here today. I guess we could start. I could direct one question to Clara. Looking forward already to the future. New Year is a month from here, but the future is always on our mind. So what are the next steps for continuing or expanding this research and project results we have done here?
So we are now a strong network of people, of stakeholders that are interested in water reuse and reclamation in the Baltic Sea region. So we decided to continue, so everyone will continue, but we are also looking for EU funds just to continue our research. We submitted also with other colleagues from similar project treating nutrients and water. We also submitted an application for Interreg Baltic Sea platforms, but I think that everyone will continue on it. And also, I really looking forward to cooperate with this group of partners. So I hope we will find just a new project. But regarding our stakeholders, our target groups, I really encourage everyone to read our handbook and contact partners, because there are data on partners, contact points, and you can just contact us and ask questions and propose a collaboration. We are open to every kind of cooperation in the future.
Indeed. Thank you. Thank you, Clara. Then we had one question in the chat. It was asked that what would be the first steps for a wastewater treatment plant to take to start using reclaimed water? And I think Marcena also perhaps a little bit answered this question already during her presentation about the mentoring program and how we moved forward with those mentees in the program. But would there be anyone else who would like to address this question? Perhaps.
Maybe, yes, yes,
Yes.
okay, Monica.
I can answer. Yes, I think that we can taking two approaches. Choose a water reuse target, perform qualities studies, and add processes to that achieve the required standards. Or first analyze the result of water quality test after treatment and decide for what purpose can be used with the minimal technical effort, for example. So first of all, we need to start what kind of water we have. So it means that it is good to test our water in wastewater treatment plant. Then we can decide how we would like to manage of it. So it is my opinion about it.
Yes, fully agree, and would like also advertise our tools. So IT tool, very good for first assessment, and also a lot of knowledge in the handbook you can use for starting point.
Yes, so if I may add something, totally agree with this approach, and also the knowledge that we gained during this project. This is not the top secret knowledge. We share this knowledge with everyone during our events, and what I could recommend to use this handbook because everything is there. One topics are described more in detail, the another ones not, but you have the main information that something like IT tool was developed, business models were developed, the technologies are described very detailed in our handbook. It's also very important. Risk management has been done, mentoring program has been implemented. So this is really guide for the future users who would like to implement the water reuse technologies. So very recommended to use it for you.
Indeed. Then we could move on to the next question. Can you estimate what share of municipal water demand could be met with reused water? Do we have any expert comments on this or estimates, perhaps?
So maybe I can answer. I think it's depend on what purpose can we use this water, because if we can work with industry, we can use even whole stream of the water. So it depends on what will be the receiver of the reclaimed water. And this is where maybe I add something to the question before. I think that very important is also regulation, because now we have only regulation for reuse water for agricultural purpose. So it is very important to implement a new regulation also for another use. Thank you.
Thank you. Then there's also actually a very interesting question in the chat. We just recently had a stakeholder forum in Vilnius in Lithuania this autumn, and there one speaker actually pointed out how big of a share the industry and agriculture actually uses the fresh water. So now we have a question here asking, is there a need for a project that promotes the use of reclaimed water in industry? So promoting this more to the industry and making them aware of reclaimed water use.
I should say that yesterday we had a very interesting meeting in Warsaw Waterworks, and industry was present, and really it is really a big industry, power plants and also petrochemistry, so really big industry, and I think that they are interested, and really they would like to implement circular economy solutions and decrease their water footprint by water reclamation and reuse. So in my opinion, the potential of cooperating with industry is very important. However, it depends on site. If you have a neighbor that is close and you can share, for example, distributed wastewater with this.
Yes, indeed. Then reminder to the audience also, you're still able to place some questions there. And while you're waiting that, I like to have this one questions. What are the main barriers to scaling up the demonstrated technologies or practices? So I've been talking about how making everything is possible, but what are the actually the barriers and what we need to note and pay attention to? Maybe this is also to you, Anna, these questions.
Okay. Well, I said in the last few sentences in my presentation that I think the most important is for us in an infrastructure to have a space for the installation, because if we have infrastructure with a high capacity and preparing such a huge amount of wastewater, reuse it and build a proper infrastructure for this. So we need a lot of space and time to do that. And also, I think that another barrier is, I don't want to say it again, but regulations. And we need to have a very strong regulation for water reuse. And the main problem with working with industry, as Clara mentioned, because I know who she was talking to in our meeting, the main reason why we cannot work with industry is regulation. So I think it would be the three kinds of barriers: low, economy, and technical. And I think that the law would be the first one.
To this regulation, I can add as well, that situation that, yes, we have this regulation about how to use for agricultural purposes. In other case, we have this urban wastewater treatment directive, which are giving us, focus that we need to treat, for example, the nutrients which are included in our water. So I think that it could be nice if our project could meet, in governance level. That there is needed some changes, for example, some acceptance for those wastewater treatment plants who would like to use it for some other purposes or even for agricultural purposes, because now we have to reduce mostly nutrients in in wastewater treatment plants water. So I think that it could be nice if someone will be interesting with our results in our project, how to change those regulations and make this smoothly for wastewater treatment plants. Some acceptances when we need to using this reused water.
Yes. So definitely time to bring the policymakers to the same table, same tables with us. Then we have a question from the end user side. How does the cost of reclaimed water compare with non-reclaimed water? So coming back to the business and cost side of this.
Okay,
Yeah,
so maybe it's
okay,
the question
Marlena.
for me. I will start, Clara, and you will clarify, I hope. So our business model concept was not taking account the economic evaluation. This is something what I have underlined during my presentation, but this is extremely important question regarding the circular economy products in general. Unfortunately, in many cases, there are more expensive than the regular products that are offered during the implementation of some of the technologies or the products that are offered on the market. However, the support for the circular economy products and services from the national and European funding is also a very important element here. So I'm not sure about the water for now. From my knowledge, the reclaimed water is more expensive than the regular one because of the usage of the additional treatment method that we have to pay for the energy, for the resources, for the technology, investment cost, and so on. But in the future, regarding the access to the resources that we have to have if we would like to stay alive and paying for something, so resources will be more important.
Yes, I fully agree with you. I think that we have also looked at I will go back again to the legal aspects, because legal aspects are also there. If there are groups of stakeholders that do not pay for water, but they use a lot of water, so our sectors of economy using a lot of water, but they pay really small amount or even nothing, it is not fair toward other stakeholders. So that's why this legal aspect and just paying for water services is very important. And the second issue, I think that is this, you mentioned, Marzena, this in the business model, this value. So maybe we should make LCA, life cycle assessment, or really show all elements of a solution, not only money, but all profits or cost benefits we have, also environmental. So it depends on the local conditions as well.
I would like to add from my side, that's a bit tricky question, because it depends from the country you're living. If you don't have any access of the water, actually you don't care about the money anymore. So you're just using the resources you have available. And environmental protection is also very money and time consuming. We cannot really evaluate everything in expenses or in a monetary way. But if you look from the perspective, if you have available water resources like underground water or using the reclaimed water as an alternative, so that's what I've been trying to bring to the audience, that for the small facility, it's always an issue. If you have a dry summer and the hot seasons, and it's happening more and more and more year by year, we know that we are suffering from the technical damages. And if we calculate the drinking water facility operating at the maximum level and the potential damages by extremely high usage of the drinking water for the lawns and the gardens and the flowers, whatever, the risk to cause the damage is much higher in terms of the expenses. So we have to evaluate that part. And that's why we have to start with the risk assessment of the every facility of the every village or every town. What kind of the problem we're trying to solve? It's a pretty complex issue. So let's remember, if we don't have any water, don't look on the money. So we have to find water to survive. So no water, no life. Thank you.
Powerful statement in the end. We are closing to the end of our webinar, but we still have two more questions. One of them being, where can we find the effects of wastewater effluent reuse on plants' growth, yield, and nutrients use efficiency, especially. And to address this, on our project website, you can find the handbook, which was presented here. So we have some results there, but unfortunately, not every result could be included in the handbook. But to complement the handbook, we also have separate research paper studies conducted during this project. So also those are available on the project website, publications. And then, do I have more comments on this, or shall we continue to our final question? Okay, so this is maybe more holistic one, and it's a good way to end this webinar, because we have a question asking how using reused water can improve the status of the Baltic Sea.
This is a very good question. We can, I think, devote 1 hour on discussing about it. But I think that we've proven it in our project, that recirculating water and nutrients, it is an issue to care about our Baltic Sea region and our sea. So preventing from eutrophication, for example, it is just recirculating nutrients. So we use less fertilizers because we use these nutrients which is into wastewater. And yes, the current directive doesn't allow it, but the future directive, so this new one, we can just reduce tertiary treatment to keep more nutrients in reclaimed water. So I think that this eutrophication is addressed in our project, and it is very important. I don't know, maybe Oskar can add also some issues about eutrophication, but
well, actually, like this Baltic Sea, like I would say, are holistic because it accumulates all activities. This we can get also nutrients not only from wastewater treatment plants, but also like naturally as well. But in this case, of course, when we like estimating these databases for pollution cases and so on, then of course we can see that wastewater treatment plants produce quite a lot of these nutrients, which enters, of course, in surface waters, rivers, and then finally reaches also the sea. But in this case, if we like apply this water for agricultural purpose or just growing the algae, we can assimilate these nutrients in the biomass, and therefore like by using all these nutrients which can enter actually in the surface waters. But again, of course, in some cases or it's smaller or bigger facilities, not all water flow could be probably or will be need for this like reclaiming, and therefore like always can be also paid attention how actively is working existing facilities. Maybe there can be some updates or improvements or including like latest findings in this biological treatment or And for the big ones, of course, will be like the next stages will be needed for absorbing microplastics and emerging pollutants in the future. And therefore, like no, we can hope for the future for Baltic Sea it will be better.
Thank you. It's good to end with those notes on having hope for the Baltic Sea region and the future. So again, thank you from my behalf and from our project behalf to the audience for attending this webinar today. And indeed, if you have more questions, please don't hesitate to contact any of us. You can find all the project partners from our website and also info from there. But thank you for this and see you again.
Thank you.
Thank you. Bye.
Bye.